Having discussed the takeoff v-speeds, we will now look at how the field length requirements, in other words the takeoff distance, the takeoff run, and the accelerate stop distance are calculated. The requirements for calculating the takeoff distance, takeoff run, and accelerate stop distance are in the certification document CS25. However, there is a lot of information, and the majority of it is well beyond the scope of the learning objectives. The information in CS25 is mainly for the manufacturers of large airliners. However, a brief look into these requirements is important. In CAP 698, on page 7 of section 4, there are very simplified versions of the field length requirements. But before we look at the requirements, remember that the takeoff run is the ground section of the takeoff, in other words, from brake release to liftoff. However, in the following requirements, you will see that the safety margins are introduced, which means that the net takeoff run is longer than the actual gross takeoff run. Let's take a look at the first of the field length requirements, which is the takeoff run. This is shown in Part A. The requirements state that the takeoff run is the greatest of the following three distances. The first distance assumes a dry runway and that all engines are operating. This first distance is the total distance from brake release to VLOF plus half the distance between VLOF and 35 feet, factorized by a total of 1.15. As an example, let us pretend the distance from brake release to halfway between VLOF and 35 feet is 1,747 meters. This is then multiplied by 1.15. Multiplying 1,747 meters by 1.15 makes the total distance 2,009 meters. The second distance assumes almost exactly the same as the first, except this time one engine is inoperative. This second distance is the total distance from brake release to VLOF plus half the distance between VLOF and 35 feet, assuming the engine failed at VEF. As an example, let us assume that this distance is 1,950 meters. The third distance assumes a wet runway, and that one engine is inoperative. This third distance is the total distance from brake release to 15 feet above the takeoff surface, assuming the engine failed at VEF. Lastly, as an example, let us assume that this distance is 2,001 meter. Once these three distances have been calculated by the manufacturer, the greatest of the three is then published as the certified net takeoff run required. In our example, the net takeoff run required, therefore, is 2,009 meters. In the exam, you will be presented with various distances, and you must be able to work out which of the distances is selected as the net takeoff run. The next of the field length requirements we will examine is the accelerate stop distance. This is described in paragraph B of CAP 698 as shown on screen. It states that the accelerate stop distance on a wet runway is the greatest of the following distances. Firstly, the sum of the distances necessary to accelerate the aeroplane with all engines operating to the highest speed reached during the rejected takeoff, assuming the pilot takes the first action to reject the takeoff at V1, and, with all engines operating, come to a full stop, plus a distance equivalent to 2 seconds at the V1. Secondly, the sum of the distances necessary to accelerate the aeroplane to VEF, and then allow the aeroplane to accelerate from VEF to the highest speed reached during the rejected takeoff, assuming the critical engine fails at VEF and the pilot takes the first action to reject the takeoff at V1, and then come to a full stop, plus a distance equivalent to 2 seconds at the V1. The greatest distance of these scenarios is then selected as the net accelerate stop distance required. The information described here is only slightly abbreviated from the full requirements in CS25. Nonetheless, the information in CAP 698 on the field requirements should be used as a good resource in the exam. It saves you from having to remember a lot of fairly complicated regulations. The last of the field length requirements to examine is the takeoff distance. As with other requirements, this distance is calculated as being the greatest of the following distances. The first of these distances assumes a dry runway and that all the engines are operating. This first distance is the total distance from brake release point until the aeroplane reaches 35 feet, multiplied by 1.15. As an example, let us assume that this distance is 1,547 meters, and when multiplied by 1.15, it becomes 1,779 meters. The second distance also assumes a dry runway, but this time with one engine inoperative. This second distance is the total distance from brake release to 35 feet, assuming the engine failure occurs at VEF. As an example, let us assume this distance is 1,720 meters. The third distance assumes a wet runway, and also assumes one engine is inoperative. This third distance is from brake release point to 15 feet, assuming the engine failure occurs at VEF. As an example, let's assume this distance is 1,710 meters. Whichever of these three distances is the greatest is what is used as a certified takeoff distance. In our example, the greatest distance is 1,779 meters. Therefore, 1,779 meters is the certified takeoff distance. Again, like when we talked about the takeoff run, you must be able to carry out this exercise in the exam. Therefore, use page 7 of section 4 in CAP 698 to help you when trying to answer such questions.